In this question, what we ultimately want to do is graph cos x plus root 3 sin x. So we have to go through all those steps, such as, firstly, finding the first derivative and second derivative. And they're not too hard to find. They're just normal functions, so don't read too much into it. Then what we need to do is find the values of x for where we actually would get a stationary point where the first derivative is equal to 0. So we rearrange our function to get tan x is equal to root 3x, and then from that we know that x would equal pi on 3 and 4 pi on 3. We sub pi on 3 and 4 pi on 3 in to get back into the original function to get 2 and minus 2 as our values. Test them in the second derivative, so when x is equal to pi on 3, it's less than 0, gives us the maximum turning point. 4 pi on 3 gives us a second derivative is greater than 0, so a minimum turning point. We can find our inflection points again, set the second derivative equal to 0, we solve and we get 2 pi on 3, 5 pi on 3. Draw up a table and test either side of those to see that we do get a change in concavity, so a change in the values, and then a point of inflection will exist there. And then from that we can draw that up, and you can shoot out a curve that's nice like that. There's our turning points at pi on 3 and 2, 4 pi on 3 minus 2.